Give an explanation.
Oh yeah, that too. There was that too. I forgot about that one. Yeah. Got to get some people signed up for that.
And,
Okay. All right.
yeah,
We have reached the top of the hour. So let's call this meeting to order. We have a couple of people here at home for business reasons. So I'm Diane Hall, President of the Warren Astronomical Society. We've got Vice President Jonathan Cade here. We've got Mark Kidzier and Mark Miles in the room. And I think the rest of you are all joining us from beautiful cyberspace tonight. Our feature presentation is going to be by Bob Trembley, former president. It's going to be Teaching Astronomy Without Math. And before that, we've got a brief rundown of board, subgroup, and observing reports. Okay, presidential news. Unfortunately, Mark Miles, our treasurer, has had to step back from the role. That means we are in the market for 2 board positions. We need a treasurer. We need a secretary. We would very much like it if we could staff that as soon as possible. I will be sending out an email to let the whole membership know in case there's anybody lurking out there who would be willing to step forward. But the most committed and active members of the club tend to be the people who are at the meeting. So if anybody has the capacity to join the board, we promise we don't bite. And we'd love to have you aboard. So reach out to board@warrenastro.org if interested, and stay tuned for an email. That's the big news tonight. Otherwise, we've got the Watts picnic coming up next, not this upcoming Saturday, but Saturday after next, the 25th. That's going to be the same date as the Stargate Open House. So if clear skies are a thing, we will observe following the picnic. We've got the board members are going to, and longtime stalwarts like Dale Parton and Mark Kidzier are going to be providing the ice, pop, burgers, dogs, vegan alternatives to burgers and dogs, buns, condiments, all that good stuff. Mark Kidzier has stepped up to be our grill master for the day. So we will be providing those things. We ask that anybody who comes just bring a dish to pass: chips, dessert, cookies, potato salad, what have you, cider, dessert, whichever, to make it a feast. And we are also having a small scale swap meet that day. So do bring anything that you would like to swap out, offload, donate, etc. And cross your fingers that we're going to have clear skies and not this awful smoke that we currently are dealing with from the Canadian wildfires. Other than that, issued a general warning at the last meeting that we're scaling back on full sugar pop because of an incident in Cranbrook. So if you want to have snacks at meetings, please be mindful. And we did have a real mess to clean up. Bob Trembley actually went around with a broom at the last Cranbrook meeting, but people made a mess. We like to be able to offer snacks, but we can't have it look like kindergarten stack table after meeting. Our hosts are very kind to us, letting us meet rent-free. Cranbrook opens the doors just for us. Cranbrook is theoretically a no-food institution, so you're not supposed to have snacks there anyway. They've got signs up. And we're certainly not supposed to leave potato chips and pretzel bits and cookie crumbs and all the rest of the stuff that Bob had to clean up. So just please, people, be mindful. And with that, I'd like to pass things over to Jonathan. Okay. Jonathan Cade. Sorry, he's our first vice president. He's been filling up the calendar with lots of presentations. I believe he just signed me up for the long talk at Cranbrook in December, and is working on presentations for next year. So email firstvp@warrenastro.org if you are interested in giving a short presentation of 10 to 15 minutes or a long presentation of about 40 to 50 minutes. Any astronomical topic under the sun, as long as we can trace it back to science. So space science, history, space exploration, robots, weather, all that good stuff. With that, I'll pass things over to Riyadh. I see Riyadh on the call.
Yes, hi, hello everyone. Last open house was on June 27. We started around 7:33 and we were out there all the way until about 12:45. We started out with the kind of partly cloudy and hazy sky and kind of cleared up a little bit later, but it stayed hazy. We had about 30 scouts and their parents. We had visitors, club members that showed up. We used the 8-inch refractor to observe Venus first and then the moon and a few deep sky objects. We also looked at some double stars like Epsilon Lyra, and we used the astrometric eyepiece to start doing some measurements. We started with Alberia. We have a little bit of work to do still. We do need to calibrate that eyepiece. We also had some scopes set up on the north side and the south side of the observatory. So it was kind of a nice, busy open house. We had probably somewhere around 50 people or so, plus or minus. And of course, we had a number of people that came out and helped out from the club with the crowds, and also thanks to Mark Kadzier for taking care of the leaks in the dome. He came out separately a few days before that and took care of that. Looks like that has worked. Also, Pete helped us with improving the ramp on the observatory that we walk up to the door with. So we have better fasteners that they won't rust, and we have non or anti-slip pads installed. As Diane mentioned, next open house is July 25th at the picnic. So hopefully we'll see everyone out there. Thanks.
Thank you, Riyadh. As I said, Treasury and Secretary are currently vacant. Dale Teamy has been doing a great job behind the scenes in making sure that we have meeting notes and that things are working on the back end of our ledger. But if you would like to relieve him of those duties, let us know. Over to outreach. We actually have a lot of things on the calendar. Starting off with next week, we've got on 7/24 at Lower Huron Metro Park, Adrian Bradley will be joining the nice folks at the Metro Park with a telescope or two. If you would like to join Adrian, reach out to outreach@warrenastro.org and we will hook you up with him. It sounds like a pretty cool event. I know it's a bit outside the territory that we usually serve, but you know, it seems really cool. August, multiple events at Cranbrook Institute of Science. The 12th will both feature a partial solar eclipse and the Perseid meteor shower. We will be on deck all day at Cranbrook, observing with solar scopes for the partial solar eclipse and then observing without telescopes for the meteor shower. Then 2 weeks later, the lunar eclipse will be the point of attraction. So we will be at night for Cranbrook being a lunar eclipse event. Details of those to be forthcoming, but please, we'd love to have as big a turnout as possible for Cranbrook events to help pay the rent. So if you could sign up, that would be awesome. Then we've got Astronomy at the Beach coming up September 18th and 19th. We'll be promoting that more heavily next month. We've got a presentation at the Tecumseh Library down in the south west of Metro Detroit on September 24th. And a Zoom presentation for Detroit Public Library has been added to the docket on 10/27. So that's going to be virtual. We also have some other events coming up in October. So we will be busy for the next couple of months. Again, let's hope for clear skies and no wildfire smoke. And finally, publications. Well, we've got our award-winning newsletter editor on the line. How are things going with the newsletter, Dale?
They're going swimmingly.
What's your deadline for the month if anybody wants to contribute?
What's today's date?
16th.
Okay, we got almost half a month to go.
Yeah.
28th every month.
Yeah, send in your art pieces, op-eds, observing reports, etc. by the 28th of the month to get it into the WAS.
Right, right.
All right. Thank you very much. Bob, do we have a solar report?
Myself here. Hold on a second. I didn't throw one together today because I was busy working on my presentation, but
I figured you'd be down
I
to
g- yeah, I get 90% of my information from this guy right here, spaceweather.com. So the first thing we do is go over here, and there are two big sunspots. That one's rotating out of view, and that one's rotating into view. Let's see. It says all these sunspots are stable and quiet. Yay. Over the past 24 hours, there's only been A-class flares, so no biggie. T Corona Borealis still hasn't gone nova. What a surprise. And far side sunspot report. European Solar Orbiter is looking at the backside of the sun. There are two large sunspots crackling with M-class flares, so they'll be showing up soon, probably a couple of weeks. This article right here is really disturbing. They're talking about all these constellations. About astronomers are complaining that they can't take astrophotos without getting a satellite anymore. Remember the days you didn't get one? Yeah, well, now Reflect Orbital wants to launch a huge space mirror that will project a 5 kilometer wide patch of light onto the Earth about as bright as the full moon. How does that sound like for a good idea? And they want to launch 50,000 more of these by 2035. Say goodbye to ground-based astronomy. Uh, and they say the light from these satellites will not be bright enough to start fires. That's a consolation in it. So yeah. There is no coronal holes pointing towards us right now. There's a big one on the bottom of the sun, though. Look at that. Uh, Other than that, that is pretty much what's going on with the sun today.
All right. How come all these weirdos name their stuff after Lord of the Rings?
Because it's cool.
I don't think they understood Lord of the Rings.
Nope.
Yeah.
Are we the baddies?
All right, Riyadh, what's the double star update?
Yeah, so as I mentioned before, we have that astrometric eyepiece that we need to do some calibration on, and if the sky is clear, we can do that. We don't have to have perfectly clear skies. As long as even if it's a little bit hazy, that's okay. We could still do some double star work. I also have my own old eyepiece for observing double stars. It's astrometric eyepiece from the mid-'80s that I bought a while back. I'd like to try that also at the telescope at the 8-inch refractor and see if we can calibrate that as well. So we'll have a few things to do next open house or next time it's clear at Stargate.
All right. Don't see our radio subgroup guy. Tom had some very interesting stuff that he talked about at the Cranbrook meeting in terms of a project he's got. So again, if you're interested in working on radio astronomy, reach out to the board and we'll hook you up with Tom.
I actually emailed my buddies up in the UP that have some land up there, and they said, send me more information about what this guy wants to set up that telescope. So
Yeah, very cool. Yeah, hook Tom up because he needs a bit of land to do his experiment. Okay, with that, I hate to ask because I think I know what a lot of people have been seeing lately, but have we got any observing reports?
I just sent you the pictures that I mentioned earlier. If you want to pull up the email,
Yes.
I took a few pictures of the sun this morning with only my phone. No telescope, no filter, and I was able to see, well, there was one sunspot. So we keep saying sunspots, but there was only one. And I thought that was pretty cool. I'd heard just the other day that the wildfires, create a filter
Yeah.
to be able to do that. So I thought that was kind of cool.
Dale, can you pull up the photos I just sent you from Dave? All right, sunspot pics with phone only, no filter.
Well,
Question,
Yes,
do you have to worry about damaging your iPhone when you, or your cell phone when you do that? The camera?
You know, I don't know. I don't know. I don't think so. Like, because I think that created a filter. I didn't do it for very long, so and my phone still seems to be working okay. So
I think the focal length of these is so small that it's not really a problem for the sensor, especially in this kind of smoke. I did the same. So I
Yeah.
saw Dave's post on Facebook earlier.
Oh,
I
hey,
went
Dave.
out and just handheld took my phone up, and I could see that's active region 4489 that Bob just
Wow.
showed us from the SDO. So yeah, I could see it on my phone too.
Yeah.
wow. We've also got some photographs of Mark Kedzier, who took them from Harrison, Michigan. They're not as tight focus, but they are striking.
Oh,
Let's put those up.
I'm gonna send you something else too.
Oh yeah.
It was 8 o'clock at night.
8 o'clock at night, Mark says. Incredible.
It looked like there was some kind of halo around the sun. Was that an artifact of the camera or what?
I really couldn't say. I mean, the haze was really thick, the smoke. So it was probably just the fringe of the sun. I don't think it was from the camera.
Okay, thanks.
Yeah, I want to show a couple more. I'll just share my screen real quick.
Okay,
I
brilliant.
was out with the GM Club on Saturday, and I took the dwarf and my sea star with me. Give me a second. Share window. So this is the Eagle Nebula with the dwarf mini. And then
Beautiful.
I had the that's the dwarf mini as well, and then that's the sea star.
Oh, cool.
Now I had the sea star going longer because I was trying something else with the dwarf, and then I said I'm just going to do both the same one. So the sea star was about 68 minutes worth, and the dwarf mini was probably about 45 minutes. So that's kind of cool.
Yeah, very. Thank you.
Look at all those stars.
Yeah. On that note, someone wants to borrow the dwarf mini. I know, Jonathan, you're going to get it next month, but if anyone wants to use it before then, let me know.
Excellent. So, any other observing reports? Anybody been able to see anything aside from the sun and the wildfire haze?
Well, Sunday was a nice night. So I got my 11-inch and my 77 millimeter out and had some nice things. M13 was really, really nice with the 11-inch, and the 77 millimeter, of course, is a fuzzball, but still quite nice. M92 was good with both. And with M57, I was able to see like the ring in the Ring Nebula with the UHC filter on the 11-inch.
Oh, that's cool.
And the 77 millimeter, just a fuzzball, but still nice. Epson Lyre was great with both. Albania was great with both. NGC 6633 was a new cluster I hadn't seen before, but that's really a fantastic star cluster to look at if you get a chance.
What constellation is that in?
You know what? I don't remember off the top of my head, but it's really a nice star cluster, one I hadn't seen before. M11 was good in both, and then IC 1396, also another star cluster. It was a nice night for star clusters.
Beautiful.
Don't have any pictures, but just it was only a good night so far for the month.
Yeah, hasn't been the best month for astronomy. Anyone else?
Saw a beautiful waning crescent moon 2 days ago in the morning early.
Oh, that's legit.
Yeah, it was very cool. My granddaughter saw it too.
Nice. Okay, well, since we don't really have a full meeting here at Macomb, we're not going to do a snack break because there's nothing to dismiss. So we'll take a 5-minute bio break, and after that, we will return with our feature presentation.
Back in a
Hey,
moment.
hey, Diane, before we get started with the presentation, as soon as we
Yes.
come back, can we talk about those other things I mentioned to you?
Yes,
All right. I'll wait till after the break though.
okay.
Thank you.
Hey, Dave, how are you feeling? Dave?
Sorry, I just
How
had
you-
to, I had to unmute. Pretty good. Thanks for asking.
Yeah, you went through some real crap there for a little while.
Yeah, well, I still am. I got 11 more doses of chemo to go. So
Okay, well, I'm pulling for you, pal.
I appreciate it. Yeah, it's I go back on Monday, but the first 3 or 4 days were kind of rough, and then I got better. And
Mhm.
Saturday I went out with the GM club, and I felt fine. And I'm just tired a lot. That's all.
I get it. Get it.
Yeah.
Okay, I just wondered what you were doing. That's all. I'm
Oh,
glad
I
to see
appreciate it. No, thank you for asking.
you. Sure. Who's giving the presentation tonight? I don't even know. Are you?
No, Bob is giving one, I think, and somebody
Oh,
else.
okay.
Well, I just wanted to talk about, I sent the board a few things via email, and I wanted to just talk about them before we get into the presentations.
Yeah, okay, good.
One of them was the using the dwarf mini. So,
Oh, good. Okay. All right. Well, I'm here to see it.
cool.
Hi, this is Allison Bentley from Southern New Hampshire University Admissions. Please call us at 888-387-0861. We would need the digital high school document completed to process your application. If you're having any difficulty at all,
Please
we have
mute.
admissions
Dale, can you
counselors
please mute
available
this?
until 8 p.m. Eastern
So
Time,
somebody's personal
7 days a
information
week.
doesn't go out on YouTube?
Please let us know what we can do to
Dale,
help.
can we? Okay.
You guys see that?
Yeah, Bob. But before you get started, I wanted to share something too. So
Oh, okay, here.
I just wanted there were a couple things I wanted to
Go
talk
ahead.
about that before we
Go
get into
ahead.
presentations.
Do it. Wow, look at everyone here. Look at this. Hi, everyone. So I had a sleep study last night. I had to go in. Man, I looked like Bob of Borg. I had things, wires just coming off me like
Been there,
crazy.
done that. Do you have sleep
Man.
apnea?
I used to, but I lost 80 pounds, and I don't think I do, but they wanted to check to see if I still did.
I lost a lot of weight, and then it was gone for a while, and then it came back
No, well,
without gaining the weight.
I'm hoping that's not my situation. Then again, I need to lose more weight.
Yeah, so I just put into ChatGPT about the wildfire. Wildfire smoke can act like a natural neutral density filter, making the sun appear dim enough to photograph with a phone.
I just put a link in chat that shows wildfires in the US and Canada, and boy, it's scary. Yikes. I should have thought to take a picture of the sun with my camera. I'll be doing that tomorrow.
All right, wanted to talk briefly about something that Jonathan and Dave Noble are interested in, which is called astrophysics. Take it away, Jonathan.
It's astrospheric. There's no fear involved. But basically, there's this website and app. It used to, Dave, do you know if it's available for Android as well as iOS?
Oh yeah, I have an
Okay.
Android. Yeah.
I thought Apple bought that, or maybe I'm confused with somebody else.
Oh, I
But
did type astrophysics, didn't I? I sure did.
yeah. So Astrospheric is a extremely advanced weather forecasting site. You may have, if you've been to the Stargate weather page on the WASP website, you may have seen the very large astrospheric widget there. I'm going to briefly show you on my phone what it looks like, but it is, well, I don't know how well you can see this, but it's basically like the clear sky clock on steroids or some other service or some other
Hey,
performance
Jonathan,
enhancing. Yes.
would you like me to share what that looks like?
Oh, sure.
Okay, I'll do that. Go ahead and continue talking.
All right. So here's the deal. We can all have the pro level functionality, except for we can't get rid of ads for free as a club because they are astronomically oriented. They have free membership for their pro
Gimme.
subscription
Gimme.
for astronomers. But there's a catch.
Oh, the catch.
There is a group for the Warren Astronomical Society. We need to have 20 people in that group in order for us all to get free subscriptions. So I think we're pretty close. I think on this call we're pretty close, but I'm gonna put together some information. I think we may have used up our email allocation for MailChimp from the month, but I am going to put together an email, and my goal is by the end of August to get free subscriptions to everybody and make that a bonus of membership. So
The Ford Astronomy Club does that. They if you're a member there, you have a free subscription to this.
Yep.
And I've used this app for years and just love it, you know.
Yep.
Yep, same here.
Yeah.
That's what this is. I'm assuming you can see it, right?
Yep.
Yep.
And
Yep.
so if you can join, so it's on that subspace tab, Doug, if you want to show the subspace tab. And you can search join group. And I'm not sure if we show up yet. I think we need a second admin before we show up.
I thought you were
But
gonna make
if
me
you
one.
just search for Warren Astronomical Society, looks like not yet. So
Weren't you gonna make me one?
I have a code. I think Dave Noble was gonna join. I
I'm
don't
in
know
it.
if it happened yet.
I'm in
Oh,
it.
you are in? Okay.
Yeah, you were gonna
Well,
make me
maybe
you
we
were gonna
can make
make
it
me
public now. So anyway, watch this space. I actually pay $3 a month for this app. So
There's
I'm
the smoke map.
Yeah,
Ew.
That's
pretty
Ew.
bad.
Hey,
It's
Doug,
got- yeah.
make that larger screen and then animate it. They have a pretty good animation of the smoke there. It's
You know, this is
That
also
play
really
button,
fun for
the play
ISS
button is in the upper
flyovers.
right. So in the upper right of that, it's the play button.
yeah, if you just click on the map, it'll make it larger, and then there's like an animation thing there. Yeah.
Hey, Jonathan, can I put that code in our chat?
Yeah,
Hi.
please. Yeah, put it in the yes on the Zoom chat, but not on the YouTube chat.
Right.
I mean, honestly, I don't know if it's yeah, so if you just grab that code and then in the astroperic subspace search, there's an option to enter a code. So if you enter that code, then you can join the group.
This app is also great for looking at ISS flyovers because it shows all of them.
Yeah, it's
At a
like
glance, you
there's a
can really see
lot
them.
of so this is I basically was spending like 3 hours a day looking at this before the last eclipse in Indiana. So this app helped us actually be in a place where we saw the eclipse. So, you know,
So here's coverage. Here's the normal display of cloud cover. And this button here brings up the 3 other models.
that's really cool.
Yeah.
Yeah, it kind of seems overwhelming at first, but eventually it starts to make sense. And like even the default view tells you a lot. So
Yeah, that's the default view right there.
all right. Yeah, Dave, if you wanted to talk about that Kickstarter, we shouldn't promote it per se, and I would ask everybody to remember that Kickstarters are not purchases. If you spend money on a Kickstarter, it could just disappear into the ether. So only spend money on Kickstarters that you can afford to lose. But if you wanted to give people a brief word about that.
Yeah, there's a guy named Josh out in Washington created. I'm gonna share my screen, but I can play the video if you want, but I'll just share the screen and share the picture. Or I'll play it without sound. Active Windows. It's just a little device, a little guidance system, about yay big. Do I have my camera on? I think I do. And it uses an app that he created to help you find what you're looking for in the sky. You mount it on the top of your scope on your tube, and use the app, and it'll show you exactly what you're looking at. So if you don't have, I hope to speed up the process of finding what you're looking for. So that's all it is.
Is that like Pi Finder?
I'm not familiar with Pi Finder, so
It uses a Raspberry Pi and a tiny embedded camera, and it does mini plate solving.
Okay,
Wow.
so there's no camera in it. It's
Okay.
just a sensor, I think. Yeah. But
Okay.
I'll put the link in the chat, and then you guys can look at it on your own.
Yeah, one thing I would point out, there's only 23 backers. It only has 2 weeks left to go, and those backers are in for about $150 a piece.
Well, but no, if it doesn't get funded, then you don't get charged.
Yeah, if it doesn't get funded, but what I'm saying is he doesn't have a lot of cash cushion if something
Right.
costs more than he expects.
Right.
So this is $8,000 might be cutting it pretty close depending on how involved the manufacturing is. So just only do Kickstarters if you can afford to lose the money no matter what.
Did I share the right thing? Was I sharing the?
Yeah.
Okay.
You're sharing the Kickstarter page.
Okay, good. So yeah, there's the link. Go ahead and watch the video. And I have no interest in it other than just I backed it as well. So I just think it will be good for where I don't have my like StarSense auto line.
Yeah, it seems really cool. I just people who are not familiar with crowdfunding may think that it's a purchase, and it's not a purchase. There's no refunds. There's no it's if it gets funded, which it probably will, it could not actually work out in the end because
he did an
getting
update.
messy.
He did an update. I think he said he got 250 of his chips in. So
nice.
he said that was the hardest part. So he's going to do something with them,
Yep.
Hey, back to this astrophere thing. Do you have to enter your own email and sort of sign up and then
Yes,
join
you
the
have
club?
you have to sign up for their subspace
Okay.
group, and
Yeah.
you have to have a public username for the subspace group, and then you
Okay.
have to join the WASP one. Yep. All right. All of that being said, did you have anything else before we start the presentation? All right. So I am here now to introduce a man who needs no introduction to the Warren Astronomical Society. Bob Trembley has been a member since 2011. He has been president, first vice president, outreach, and newsletter editor. He is a volunteer NASA JPL Solar System Ambassador, and he is as a self-described factotum of the Vatican Observatory Foundation, doing a whole number of different jobs. He wears a lot of hats, but none of the pointy ones.
A lot of spaghetti gets thrown at the
He
wall with me.
he is a huge science fiction fan and an asteroid fanatic. You're likely to find him at the discerning sci-fi convention of your choice on a panel somewhere. And one of Bob's goals is to see astronomy taught better in public schools in the US and presumably beyond. And to that end, he's going to be talking to us about astronomy with no math. Bob,
All
take it away.
right. Hi there. All right. This is actually going to be a review for a lot of people, and there's some new information. I actually learned some stuff, and there's a couple things that are only a couple weeks old. So, anyway, when I was a young boy, I loved astronomy, right? 8 years old, I had a telescope, and I had the opportunity when I was in high school to take astronomy from my favorite science teacher. I found this picture. This looks amazingly like my science classroom, the granite countertops and all that. That was great. I loved it. So I took astronomy from my favorite science teacher, and I just hated it. All I remember is that we calculated the distance from the Earth to the Sun using a Venus transit and trigonometry. That is not what I was expecting. And I don't know what I was expecting, but it wasn't this. And I've heard similar stories from other WASP members. So that's a great way to turn people off of astronomy. So I could have taught that class. What was not covered was all the cool stuff. I mean, how many of you have set up a telescope and have somebody do that? Like go, wow, probably a lot of you. And when I took my telescope to my wife's school and showed the kids the sun and stuff. So a lot of you set up telescopes and had first timers look through a telescope, and people my age first time. I mean, that should have happened when they were in middle school, personally. So you explained what they were seeing, you pointed them to more information, you didn't ask them to do math. So, what would I teach? Well, well, let's get started. Okay. So the first thing, a lot of city dwellers can't see stars at all. I took this picture in 2012 when I went to Alcon, and this was on the Chicago River, and I could not see one single star. And this is the reason, because there's a lot of light pollution in Chicago. This is a picture of Chicago from the International Space Station, and you can see city streets. Now, if I can see these lights, they're pointing up and not down at the streets, which is bad. And this is a nationwide and a worldwide problem. This is Michigan this is NASA's Black Marble website, and you can do time lapses of the growth of light pollution. It's pretty depressing. So, night sky from a dark sky site is absolutely breathtaking. It's a picture by Adrian Bradley, and everybody should go to a dark sky site and see the night sky. And one of the biggest concepts in astronomy is that space is big. It's really big. And this is the quote from The Hitchhiker's Guide to the Galaxy. And they said it pretty much the best. Arguably, one of the most important concepts in astronomy is the size and scale of the universe and the distances between objects in the universe. It's almost impossible for human mind to grasp the scale of the universe. This is a poster that came with National Geographic, a fold-out when I was a kid, and my wife had this in her classroom as a poster. This always remained with me. It just shows the scale of the universe. Keep going on there. So Alpha Centauri, or actually Proxima Centauri, I should have said, is the closest star to us, and different vehicles will take like geologic timescales to get there. Even if we had an Epstein drive from the Expanse, it would still take 6 years to get there. Parker Solar Probe, the fastest vehicle mankind has ever made. You got 22,000 years? I don't. As it would take a long time to get even to the nearest star. And when I explain this to people, I hear them say, that makes me feel really small. You've all heard that, right? Well, I would counter that argument is your size is just fine. You're the perfect size to be able to contemplate the awesome scale of the universe without all the complications of being so large that gravity pulls you into a sphere and starts igneous processing. I imagine that would be pretty uncomfortable. Now, but think at it from the other perspective, honestly. Look at it the other way. Imagine how a microbe in your gut would feel about the size of your body. It would be almost astronomical in size. There was a video in 1977 called The Powers of 10, and this is made by IBM. It does a pretty good job of showing the scale of the cosmos. It starts off at a picnic scene in Chicago and zooms out to super clusters of galaxies and then back to the picnic scene and down to the atomic scale. The video was produced way before computer graphics, and there have been several more recently produced that do have computer graphics. There's an app on Steam called Orders of Magnitude, which I showed at the meeting a while back. This thing is like an interactive version of the Powers of 10. It takes you a bit further in both directions, down to like the Planck scale and out to the edge of the observable universe and into the multiverse, which is total science fiction. So I'm not going there. So back to space is really big. It is really big, and light has a speed. It's really fast, 186,000 miles per second, but it's not infinitely fast. So for your human experience, events around you happen essentially instantaneously. Not so when you're talking about distances in space. So the distances between the stars is so great, light can take years, century, or millennia to reach the Earth. So space and time are inextricably linked. The night sky is literally a time machine. Not that one, but maybe a different one than you were thinking about. So what is now? So if an Iridian, I'm referring to Project Hail Mary here, if an Iridian on the 40 Eridani star system was looking towards our sun, they would see light that left our sun 16.3 years ago, and Earthlings, on the other hand, would see light that left 40 Eridani 16.3 years ago. Which of those two is now? All depends on where you are. So aside that frozen Earth I made with the App Universe sandbox, I set the sun's output to 0.9 on the simulation run for about a decade, and yeah, it's bad. It's very bad. So until the invention of the telescope, human eyesight and math was how astronomy was done. So this is the early 1600s. Thing is, human eyeballs they may be pretty, but they're awful astronomical instruments. You can only see a tiny portion of the electromagnetic spectrum. Until the discovery of infrared light by Sir William Herschel in the 1800s, we didn't even know about invisible frequencies of light. UV was discovered the very next year, and then we kept finding more and more invisible frequencies. So much of the universe is invisible to humans. The Milky Way looks way different depending on which frequency you're looking at. So this is a multi-wavelength picture of the Milky Way, and ours is, where's my laser? Here's what we can see. Where's my laser? There we go. That's what we can see right there. But looking at different frequencies, it's quite spectacular. So here's the Horsehead Nebula. Stars can be seen hidden by nebula, invisible light in the Horsehead Nebula, but when in IR, those stars shine right through. The same with the Pillars of Creation in the Eagle Nebula. Just look at all those stars that shine through the dust and nebulosity here. It's crazy. So looking at the Milky Way in X-ray shows huge bubbles of hot gas with temperatures up to 10 million degrees expelled from the plane of the galaxy. these bright zones. There are some really bright splotches, which are X-ray sources, which I'll be talking about a little later. So radio waves were predicted mathematically, which I didn't know. They were predicted mathematically in 1867 and then confirmed and generated in 1887. Maxwell's equations are a set of four partial differential equations, pretty heavy-duty math, that form the foundational core of classical electromagnetism, optics, and electric circuits. Formulated mathematically by James Clerk Maxwell, they describe how electric fields and magnetic fields interact, propagate, and are generated by electric charges and currents. So, yeah, kind of important math and explaining. I'm not explaining any of it, and it won't be on the test I'm not giving at the end. This is a brother guy wearing the shirt that has Maxwell's equation that says, and God said, and then there's all these equations, and then there was light. Pretty darn funny. So the cosmic microwave background radiation is the faint leftover radiation from the cosmic genesis. The term Big Bang was actually coined by Sir Fred Hoyle as a derogatory term. Anyway, the cosmic microwave background is the oldest light in the universe. It fills all space. It's everywhere. Emitted about 380,000 years after the universe began, it serves as a baby picture of the cosmos, providing vital clues about the universe's age, composition, and origin. Now get this. The present-day energy density of the cosmic microwave photons greatly exceeds that of all the photons emitted by all the stars over the history of the universe. Without the expansion of the universe to cause the cooling of the cosmic microwave background, the night sky would shine as brightly as the sun. Yikes. So, light emitted from hot elements like stars or light absorbed by cold gases like clouds in space display a fingerprint on a spectrum of light. Note, ultraviolet and IR regions of the electromagnetic spectrum also feature their own unique spectral lines, but they don't go much further than that. Across the massive continuous spectrum of radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma rays, spectral lines only cover a tiny fraction of frequencies, and we can see them. How lucky are we? So, oh, I didn't know it was animated. That's cool. With this discovery, spectroscopy was born, the branch of science concerned with the investigation and measurement of spectra produced when matter interacts or emits electromagnetic radiation. It is a fundamental tool used in the fields of physics, chemistry, and astronomy, allowing the composition, physical, and electric structure of matter to be investigated at the atomic, molecular, or macro scale and over astronomical distances. And if that isn't completely wow-worthy, I don't know what is. I believe Tim Campbell gave a presentation to the WAS about this a while back. So Father Angelo Secchi was a Jesuit astronomer who was the first one to ask, what are the stars, rather than where are the stars? He built an observatory with a spectroscope on the roof of the Church of St. Ignatius in Rome and looked at the spectrum of several stars. And the story of Father Angelo Secchi is long and sad. It was a time of war filled with politics, and Brother Guy calls him the greatest astronomer you never heard of. This is a model by Brother Bob Mackey, 3D printed and painstakingly built. And there's the observatory from the mid-1800s, the spectroscope on top of this church. So, getting on to stars. Stars are self-regulating thermonuclear fusion reactors, or was it, what does the song say? The balls of incandescent. I can't remember the name of that. Incandescent gas. So, our sun's a star. It's a main sequence star, about halfway through its 10 billion life year lifespan. Has anyone gotten the sun isn't a star, it's the sun argument? Anyone? Anyone? I haven't heard that. My 6-year-old granddaughter knows the sun's a star. She doesn't seem to have a problem with it. Probably because she was taught from an age of 6 that it was a star. So the sun contains 99.86 of all the mass in the solar system, and that just blows me away. It's the solar system. Well, there you go. It's all the sun. Sun is not yellow, it's actually white and then some. It radiates light across the UV spectrum from the far UV to the far IR. So stars come in a variety of sizes and quantities. When you talk about the number of stars, our sun is bigger than 80% of stars, which is just a fancy way to say that there's a great number of stars smaller than our sun. However, there are some stars larger than our sun. The larger the star is, the fewer of them there are. This guy right here I'm going to be talking about in the next slide. This is Alnitak. It's a blue supergiant star, 21,000 times brighter than the sun. That just blows me away. Now, the lifespan of such stars is only like 1 to 20 million years. So in about a million years, this star is going to expand into a red giant wider than the orbit of Jupiter before entering its life in a supernova, likely leaving behind a black hole. I remember Dave Bailey talking about stars this size a long time ago, and he stated that compared to the lifespan of stars like our sun, these stars are more like events than stars, and that always stuck with me. So, and there are some absolute monster stars when you talk about star sizes. Our sun is tiny compared to these. So there's Eneltak right there, that little guy right there. That was the blue supergiant. So yeah, stars can be big. So if you replaced the sun with Betelgeuse, Jupiter would heat up pretty darn fast. So yeah, Betelgeuse is large. And it was just found out in January of this year that Betelgeuse has a companion. It has a 1.5 solar mass companion that orbits every 2,000 days. So one of the brightest stars in the sky has a companion we didn't even know about until this year. So recent studies concluded that the long secondary period was best explained by the presence of a low mass companion orbiting within Betelgeuse's atmosphere. So that's cool. So we live in a sea of stars. The sun lives in a sea of stars. There are stars everywhere around us, billions of them. And this is the Sagittarius star cloud, and there are star cloud. There are so many stars, it literally looks like a cloud. And those dark areas, let me go back and come back to that. Come on, cursor, over here, please. Why are you pausing like that? Stop it. There we go. All right, so there we go. So yeah, those dark areas, it's not because of lack of stars, that's because of all the dust that's there. There's a lot of dust out in space. So, oops. So, and your eyes can't see most of the stars in the sky. Even from the darkest sky site, your eyes can't see a single red dwarf star, and they make up about 75% of the stellar population in the Milky Way. So the first red dwarf was discovered in 1753. So until the middle of the 1700s, we weren't even aware of a majority of the stars in the sky. Closest star to our sun is Proxima Centauri. It's 4.25 light years away. It was discovered in 1915, and so until the early part of last century, we didn't even know about the closest star. More recently, a couple exoplanets have been discovered orbiting Proxima Centauri. And our sun would appear as another bright star in the constellation of Cassiopeia from the night sky of one of these planets. That's pretty cool. Sub-red dwarf stars flare quite spectacularly. On May 1, 2019, Proxima Centauri increased in brightness 14,000 times in the ultraviolet. Imagine what that would do to any active biospheres on those planets. It would probably scour them clean. So stars begin in clouds of gas and dust called nebula. Gravity pulls the material together, heating it until nuclear fusions begin. They then spend most of their lives in this stable phase, fusing hydrogen into helium. Eventually, stars like our sun will run out of hydrogen and will expand into a red giant, shed its outer atmospheres to form a planetary nebula, and leave behind a cooling, dense core called a white dwarf. Now, during the life cycle of a star, heavier elements get created in the star's core through a process called nucleosynthesis. Now, this was a picture from National Geographic when I was a kid, and again, it always stuck with me. I love this picture. So this is the Cygnus X star forming region. It is packed with stars and the dark lanes of interstellar dust and gas. This is the interstellar medium. This is where stars are born. And got my cursor. Open clusters are loosely bound groups of tens of thousands, 10 to thousands of stars that formed from the same giant molecular cloud. Because they share the same age and chemical composition, astronomers use them as primary laboratories to study stellar evolution. Over 1,100 of these clusters have been cataloged, and astronomers estimate tens of thousands more remain hidden behind galactic dust. Here's the leftovers of planet formation around stars. Studying them is the key to understanding the birth of planetary systems. The orange ones show the distribution of dust, and the blue ones show gas. And these are probably in the Orion Nebula. I'm not sure, but I've seen a lot of these imaged in the Orion Nebula. So as I mentioned, when the sun reaches the end of its life, it's going to start bloating. It's blown out into a red giant, and it'll just start losing hold of its outer atmosphere. And its outer atmosphere will start sloughing off and away. And this creates planetary nebulas, which are arguably some of the most beautiful objects in the cosmos. This debris disperses out into the interstellar medium and fades from view in about 25,000 years. So if you're seeing these now, you're lucky. So stars 8 times or more massive than our sun can explode in a supernova at the ends of their lives. A single supernova releases an astounding 10 to the 44th joules of energy. This amount is equal to the total energy the sun will output over its entire 10 billion year lifespan. So I've heard a lot of people say, they give presentations about stars going supernova and children going home crying about the fact that our sun is going to go. So it's not. Oh, sun's not going nova, not happening. So I got created this image by using Universe Sandbox, and I clicked on the sun and picked detonate, so that you can do that. Supernova create expanding shells of gas and dust called supernova remnants. The star's outer layers are blasted into space at thousands of kilometers per second, plowing into and sweeping up surrounding interstellar gas. These remain visible to telescopes for 10,000 to 100,000 years, and like planetary nebula, they expand and cool and eventually disperse into the interstellar medium. Exploding stars can create neutron stars and pulsars. They can crush the star's core down into ultra-dense neutron stars or rapidly spinning pulsars, which emit powerful sweeping beams of radiation from its magnetic poles. They can also create black 20s. When a star is 20 times more massive than our sun goes supernova, it can leave behind a ludicrously dense core that can become a black hole. Here's a visualization of a free-floating black hole. The only way you can see it is from the bending of light around it. Kind of creepy. And this is fairly recent news. Some large stars can collapse directly into a black hole without going supernova. They saw this star that should have gone nova just vanish. It's called a failed supernova. In this scenario, the core of the star collapses to form a black hole. The surrounding matter formed a burst of neutrinos that lowered the total mass of the star by a fraction of a percent, and this caused a shock wave that blasted out the star's outer envelope to make it brighter, but it did not go supernova. So that's interesting. So astronomers estimate that there are approximately 100 million to a billion stellar mass black holes in the Milky Way galaxy. While this number seems high, only about 50 or so have been confirmed or suspected through observations, primarily because they're invisible, roaming freely through the interstellar medium without a companion. But remember, space is big, so don't worry about it. Cygnus X1 is a high-mass X-ray binary star located about 7,000 light-years from Earth, famous as the first object widely accepted as a black hole. It consists of a blue supergiant star orbiting an invisible compact object that is roughly 21 times the mass of our sun. It was discovered in 1964 by a rocket flight as one of the strongest X-ray sources detectable from Earth. It remains one of the most studied astronomical objects in its class. And here's a zoom out showing how the stars orbit a common Berry center. So many of the stars in the sky have companions. Some only look like it. Here we have Albireo, which is beautiful through a telescope. More than half the stars in the sky are part of a binary or multiple star system. This is Albireo. Wikipedia says it's not known if these two stars orbit each other or if it's an optical double. However, the Gaia mission recently, and you can search this on Google, the Gaia mission has determined that these two stars are not gravitationally bound, so they are an optical double. They are not optically bound, and their velocity vectors are in completely different directions. So, and again, recent news. Riyadh talked about Epsilon Lyrae, I believe, the last meeting, and so I went and found it and put it in here. So many of the stars have multiple companions. Epsilon Lyrae is a double-double. And zooming in, and this is a simulation of it, we've got two stars. Turn the laser back on. We got two stars right here and two stars right there orbiting their common center of gravity. So that is really, really neat. T Corona Borealis. This is one I mentioned earlier today, located 3,000 light years away. Contains two stars that orbit each other, a red giant nearing the end of its life, and an Earth-sized stellar remnant known as a white dwarf. The dwarf's intense gravity rounds up gas flowing off the red giant, forming a flattened cloud around the dwarf and accretion disk. Gas in the disk gradually works its way inward, eventually flowing onto the white dwarf and resting at its center. Despite the powerful and eventually it's going to explode. And despite the powerful explosion, the dwarf remains intact, and once things settle down, it begins a decades-long preparation for a future fireworks show. This was predicted to go off, I believe, a year ago now? It's supposed to go off any time now. So let's talk about the solar system. You can see, you can use NASA Eyes on the Solar System to see. Oh, pen, go away. Stop that. All right. Anyway, so let's talk about the solar system. Before 1962, it was believed that Venus was a beautiful, lush world, and some science fiction shows would have you believe that there were scantily clad women living on them. Whatever, I didn't make the movies. So, but December 1962, the Mariner 2 flew by, and Venus became a hellhole with a runaway greenhouse effect and no lush forests. Interesting recent discovery was Rebecca Hahn, when she was in high school, analyzed 30-year-old data from the Venus Magellan probe using machine learning and found an enormous, like 80,000 volcanoes on Venus. She and Paul Bryan published a paper about it in 2022. So hopefully we go back and find active volcanoes. That would be very cool. So Earth is the only planet in the cosmos we know of that has life. Earth has a very large moon. It's a perfect distance to occasionally block the sun in spectacular eclipses. And what does every first-timer ask? When's the next one? I even heard that the last time. Earth's thick atmosphere protects us, ground dwellers, from most of the 100 tons of space debris that hits the Earth every day. Meteor shower is a celestial event which a number of meteors are observed to radiate or originate from one point in the sky called a radiant. Meteors can be fleeting or tumble across the sky from horizon to horizon, which I've seen. During typical meteor showers, you'll see 1 to 2 meteors per minute, about 60 to 120 per hour. Meteor showers occur when the Earth passes through streams of dusty debris left behind by comets. And as these cometary fragments hit the Earth's atmosphere at high speeds, they burn up and create bright glowing streaks known as shooting stars. There have been some instances where about 1,000 meteors per hour have been seen. This is called a meteor storm, and I'm waiting for one. I'm impatiently waiting for a repeat of the 1833 Leonids meteor storm, and I have to wonder about 9 months after this how many babies were born, because that might have been really scary if they didn't know what was going on. Sometimes meteors can be really big and level forests. I heard about the 1908 Tunguska event from Carl Sagan on Cosmos in 1980, and I was shocked. What happened here is something exploded in the sky, much like the Chelyabinsk event, and it flattened forests like over 80,000 square kilometers. It was huge, and it would have covered Washington D.C. if you put it over on a map. So yeah, amazing event. Okay, Earth has life, and there's some life on Earth called extremophiles that live and thrive in habitats where life would be impossible for most living organisms. A Morning Glory is a hot spring in Yellowstone. It is 157 degrees Fahrenheit. It gets its vibrant colors from thermophiles, which are heat-loving extremophiles. Um, Hydrothermal vents are fissures on the seabed from which geothermally heated water discharges. They are commonly found near volcanically active places. These were first discovered in 1977, and around them are rich ecosystems in this harsh environment. So there are also extremophiles which love the cold. So keep that in mind. These guys are organisms that thrive in permanently freezing environments such as deep sea oceans, glaciers, and permafrost. That's just crazy. So life on Earth can be very hardy. I scraped this picture from the NASA Mars site this morning. It's the only planet we know of inhabited entirely by robots. So NASA's getting a little bit cheeky on their Mars website, but it's true. So Mars has the Mariner Valley or Valles Marineris. This is a canyon system, the largest canyon system in the solar system. It reaches over 4,000 kilometers. Mars has the largest volcano in the solar system, Olympus Mons. It is a shield volcano which last erupted 25 million years ago. I got some interesting angles on it here in Space Engine. Io, Jupiter's moon, is the most volcanically active body in the solar system. Its surface is covered in scorching lava lakes and sweeping sulfur fields. Io has over 400 active volcanoes constantly erupting. Jupiter's immense gravity exerts force on the side of Io closest to the planet. It distorts Io's shape, causing what's known as tidal heating. And this happens to several bodies in the solar system, too. Moons of Jupiter frequently pass in front of Jupiter's face, and this is called a transit. Often that moon's shadow will also transit Jupiter. That's called a shadow transit. You can see these through a telescope, and I think we've actually seen a couple of these from Stargate. That's what the shadow looks like if you're hovering above Jupiter's cloud tops. So, yikes, pretty darn huge. Jupiter's clouds can be absolutely beautiful. This is an image taken by the Juno probe and processed probably by citizen science. I know there's a lot of guys doing that, but this is just wall art. That's just absolutely beautiful. So Jupiter was hit by 21 fragments of Comet Shoemaker-Levy 9 in 1994. The entire world was watching it. The collision was one of the largest and most energetic explosions ever witnessed by humanity. Saturn's rings, what can you say about the most look at me object in the solar system? Well, a lot actually, like an entire presentation worth somebody could do. So Saturn's beautiful rings are made up of countless trillions of pieces of ice and rock. But that beauty was born in an incredible act of violence. An icy moon just got a little bit too close to Saturn. Its tidal forces tore it apart. Imagine standing on that moon as the ground around you shatters and starts to just lift off into the sky. So that stuff spread out, and that is what forms Saturn's moon. So that is why Saturn's moons are mostly ice and a little bit of rock. This is Saturn's moon, Pan. It looks like a flying saucer or a pierogi, depending on how you look at it. Pan is the innermost of Saturn's known moon. It orbits within Saturn's rings. It is responsible for keeping the Encke gap open. And that would be right there. It orbits right there. Mimas, another moon of Saturn, is called the Death Star moon for obvious reasons. The Herschel crater is a 140 kilometer wide, 88-mile impact feature with a prominent central peak. If the impactor that created the Herschel crater had been much larger, it would have shattered the moon entirely. So our solar system was violent way in the past, and pretty recently too. Neptune was discovered using math. I'm not going to go into that. It's crazy. So the orbit of the orbit of Uranus was slightly off, so mathematicians calculated on paper where something should be that would be causing that effect. And when a telescope was trained on that location, there's Neptune. They were right first try. That story is worth a presentation of its own. It's crazy. Neptune has some of the fastest winds in the solar system, over 600 meters per second. Comets, icy dirt balls or dirty ice balls, depending. They're beautiful, awe-inspiring, and recently a challenge to see, unless you have a good telescope. My family has been lucky enough to see a couple naked eye comets, Hyakutake and Hale-Bopp. Halley's Comet, sorry. Halley's Comet was the first comet to be predicted using math. So the ESA orbited a comet. This is comet 67P Churyumov-Gerasimenko. And it also crashed landed on that comet. This is animation showing outgassing as the comet rotates, and this is what creates the comet's halo and tail. Several of the icy moons of Jupiter and Saturn have subsurface oceans under their icy crust. This is Saturn's moon Enceladus. It's got massive valleys and stuff in it, and the really interesting thing is it has these geysers. The Cassini probe discovered these geysers coming out of it as it was orbiting Saturn, so they inched it up to the geysers and eventually flew it right through the geysers. And they come from a relatively warm fractures in the crust, several gases, including water vapor, carbon dioxide, methane, and either carbon monoxide or nitrogen gas make up the envelope of the plume, along with salts and silica, and a density of organic materials in the plume about 20 times denser than scientists expected. So under Enceladus's icy crust, there could be hydrothermal vents, just like on the deep oceans of the Earth. And if there's life on hydrothermal vents in the deep oceans of the Earth where there is no life, and the life survives by chemosynthesis, could be happening here too. Exoplanets. You've heard me blather on about this while I was president every single time. A favorite topic of mine. We've discovered over 6,000 of these orbiting other stars with almost 8,000 candidates yet to be confirmed. These numbers rising weekly. They are not going to go down. I love this is graphic of it. And once again, my cursor's screwing up. There we go. Okay, so we've found rocky worlds orbiting so close to their stars, their surfaces are molten. We've found Jupiter-sized worlds orbiting so close to the star that their nighttime side glows and the daytime side are incandescent. Some of those hot Jupiters are having their atmospheres boil off into space because they're so hot. So they have a comet-like tail. So there's a lot of exoplanets out there, and we haven't discovered an Earth-like one yet. There are missions out there within the next couple of years that are looking for Earth-like planets orbiting sun-like stars. So soon. So stars are born in cold and dense nebula. Gravity pulls the gas and dust from the interstellar medium into what are called stellar nurseries. And this is where stars are born. The interstellar medium is a diffuse sea of gas and dust and cosmic rays that fill space between the stars. It makes up about 10 to 15% of the visible mass of the Milky Way, and it contains a lot of elements, as you can see, and you can put a lot of interesting things together with those elements. So the interstellar medium is a vast chemical factory. You've got stars that are intensely bright, pouring out UV radiation, and it cooks a lot of different complex molecules, including organic molecules, and a lot of precursors to life. They're everywhere. They're finding this stuff everywhere. They've also found water. These are observations by NASA's SphereX, which launched just recently, reveals vast frozen complexes in the Cygnus X star-forming region I mentioned earlier. Water ice, shown as the bright blue, exactly overlays dark lanes of interstellar dust. The article says that these vast frozen complexes are like interstellar glaciers that could deliver massive water supplies to new solar systems being born in the region. So lots of water out there. This is very recent news. Ribose was discovered in the asteroid samples returned from asteroid Bennu. So the stuff of life is everywhere throughout the solar system, from its formation. The ribose here is a building block of life. This is 2026 news. The precursors of life have also been found in asteroid, comet tail samples, and meteorites. So, stuff of life there to begin with. So our sun is one of hundreds of billions of stars that make up the Milky Way galaxy, and here's a top and a side view of the galaxy. It's a flattened disk of stars with a central bulge about 100,000 light years across. Milky Way has a halo that's enormous, a roughly spherical cloud of dark matter, hot gas, and ancient stars that envelope our galaxy's disk. Stretching up to 300,000 light years across, the halo acts as a gravitational scaffold for the galaxy and contains the vast majority of its total mass. The halo spins in the same direction and almost the same speed as the galaxy itself, and virtually every galaxy is believed to have such a halo. A globular cluster is a massive spherical collection of tens to thousands to millions of stars, tightly bound by gravity, orbiting the outer halos of galaxies. These ancient systems contain some of the oldest stars in the universe, typically ranging from 8 to 13 billion years old. Milky Way hosts roughly 150 to 200 globular clusters. M31, the Andromeda Galaxy, contains an estimated 500 globular clusters, and this is a photo of M3. So here's a simulation of M3 above the galactic disk. Around 20% of the Milky Way's globular clusters are found within 1 to 2 kiloparsecs of the galactic plane. These are called thick disk clusters. They are slightly richer in heavy elements compared to the ancient halo clusters. There are a number of globular clusters that appear to be directly embedded in the Milky Way. These are most likely being seen in the midst of crossing through the disk as they orbit. So this is M3 above the galaxy, and this is a side view. So this shows you how far up M3 is above the disk of the galaxy. Pretty darn far. So stars, they orbit the galaxy in different ways. Our sun actually orbits up and down through the disk of the galaxy as it orbits. The halo stars, they're all over the place. And the stars in the bulge, they're also all over the place. So I didn't realize that. That's pretty interesting. So our galaxy is big, and our radio waves, we've only been transmitting for about, 100 years. So our radio waves have only traveled about 100 light years out into the galaxy. And because of the inverse square law, which, like flashlight, right? If I shine a flashlight in your face, you're going to be going like that. But if I'm half a block away and shine that same flashlight, this is going to be a dim light. Well, that's the inverse square law, and that applies to our radio waves as they go out into the universe. They fade into the background noise of the galaxy. So even 100 light years away, which would be the distance our radio waves have traveled, you might just hear static. There might just not be anything to detect. So this is the Sombrero Galaxy, and again, we're looking at infrared and visible light. So, and you can see the dust lanes in the Sombrero. It looks quite different in infrared. This is beautiful. I love the Sombrero Galaxy. So galaxies merge a lot. These happen all the time, and they can form cause intense star formation along the mergers and stuff. And they occur when the gravitational pull of two or more galaxies draws them together, combining them into a single larger structure. Despite the violent nature of these collisions, actual stellar collisions are practically non-existent because of the vast distances between stars. Streams of stars can pour out of these mergers due to gravitational effects. This is called the mice. I love that. These stars are just being flung away from those galaxies. In the standard cosmological model, any single galaxy is expected to have formed from a few or many successive mergers. So, happens all the time. And James Webb Space Telescope sees it happening at the beginning of the universe. These images show 6 galaxies in a protocluster and a supermassive black hole in the dotted ellipse. So this was happening from the beginning. Galaxies have been merging. So the number of galaxies, this is pretty interesting. Carl Sagan estimated that there are some 100 billion galaxies, right, in the 1980s. Recent research from the Vera Rubin says that that's up to 2 trillion, and I'll bet that number continues to grow. So there's the James Webb Deep Field, and those are, except for only a couple stars there, those are all galaxies. And you can also see some gravitational effects here, which is pretty cool. So this is our Milky Way and the Andromeda Galaxy, and our Milky Way is surrounded by dwarf galaxies, as is the Andromeda Galaxy. It's called the local group. Let's see if I can pronounce this right. Laniakea. This is the cluster of galaxies that our Sun and the Andromeda and a whole bunch of other galaxies belong to. And you keep zooming out, and you get superclusters of galaxy. And you keep zooming out, and you get more galaxies. This is this website, this cosmicstructures.com. This is 3D interactive, and this is shows you information from the Sloan Digital Sky Survey. So you can scroll this around and zoom in. This is a zoom in. It looks like those are probably all galaxies, right? Those are all galaxies. Well, here, let's zoom out. Those are all galaxies. So yeah, there's a lot of galaxies. So again, when I went to Alcon 2012, I went to Fermilab, which my buddy works at, and this is me with a Sloan Digital Sky Survey plug plate at Fermilab. They were showing this off. The plug plates are circular aluminum discs drilled with hundreds of precise holes. By manually inserting fiber optic cables into these holes, astronomers map the exact coordinates of stars and galaxies according to the telescope spectrograph to measure their light simultaneously. From 1999 through 2021, the Sloan Digital Sky Survey used these plug plates to perform observations, and they drilled over 10,000 unique plug plates. So again, a whole presentation could be done just about this. So this is how the universe is organized. Galaxies can be found quite isolated or in groups or in clusters, and no matter their location, they are likely to be involved in a supercluster of galaxies. These superclusters are connected by filaments, sheets, and walls, and between these there are enormous voids. The web in the cosmic web showcases the interconnection between the structures, and the distribution can be visualized as foam, with galaxies in the soapy water, and the bubbles are the voids. Now, one of my first thoughts when I saw this picture of the cosmic web is, wow, that looks a lot like neurons. But that's just the science fiction brain talking. So galaxies come in a variety of shapes and sizes. A whole presentation could be done on just these alone. Again, there's our Milky Way contains 100 to 400 billion stars, which is just an enormous number. We have the Milky Way has a couple companions. These are large companions, large and small Magellanic Clouds. The Milky Way hosts over 60 known dwarf and satellite galaxies bound within 1.4 million light years. Andromeda, M31, our closest large neighbor at 2.5 million light years away, appears roughly 6 times wider than the full moon in the sky, and it contains 1 trillion stars. Well, let's see. I guess I copied those. Let's go on to that. Yeah, there we go. Yeah. All right, I copied. Oh, for crying out loud, Bob. I copied, I didn't move. Yeah, yada, yada. All right. So, some resources. A buddy of mine calls Matt O'Dowd the modern day Carl Sagan. He has a PhD in astronomy and astrophysics from the University of Melbourne. And he hosts this show called PBS Space Time. Some of the concepts are right up here and will make your head explode. And I'm absolutely serious. So some of the things are go, oh, that's really cool. Some are like, so yeah, he's pretty deep. Fraser Kane, he is the editor of Universe Today. He publishes between 30 and 50 news stories every week, which I'm sure Ken Burton can appreciate. Scott Manley, my hero, he follows rocket launches from around the world. He also made a fantastic asteroid discovery video timeline in 2012, and he's made countless how-to videos about Kerbal Space Program. How the Universe Works, my mother-in-law watches this all the time, which is awesome. I've often been sucked into an episode of this when I go upstairs to refill my coffee, which is not so awesome. But I suppose it's cool because I've written several posts on the Vatican Observatory Foundation site because of things that I saw in this show. Astronomy Picture of the Day, APOD. Every single day they post a new picture. It is one of the oldest sites on the internet. And they're on social media, and they're a fantastic site if you want to find out about what is in that picture. The James Webb Space Telescope Image Archive. I use this every week when I post the newsletter of the Vatican Observatory Foundation. There's new stuff on here, and it's just fascinating. If you want to do science yourself, this is the place to go. Zooniverse has tons of citizen science programs that you can do from the comfort of wherever your connected device is. They have several astronomy-related programs and tons of others. What are you interested in? There's probably a science project there that you can contribute to. They have a collection of papers arising from Zooniverse projects, which are the results of which show the collaborations of hundreds of thousands of citizen scientist volunteers. I've heard stories of high school students having their names put on research papers because of their contributions of this. So teachers, get your students involved in this. So astronomy is full of awe, beauty, and wonder that I didn't learn anything in school about. I didn't learn any of this in school. None of it. So astronomy, highly interdisciplinary physical science. The deeper you go into astronomy, the more fields of science you'll delve into. If you become a professional astronomer, you will be doing some math, probably a whole lot of math. But you're not going to get students interested in astronomy by throwing math at them first. Don't do it. Show them how amazing the universe is, and they'll want to come back for more. And that's my rant, and I'm sticking to it. So that's it.
All right. Do we have any questions for Bob?
Let me know if there's something I left out. I know I didn't put anything in dark matter in here. I've actually got 25 slides that didn't make it into the presentation. So yeah, I know I missed somebody's favorite topic.
You
but
missed my favorite planet.
Oh, you see?
Mercury.
Bob, you did just fine. Don't worry about it. You did. It was great. If the teachers
But
were to use your way, it would be fabulous.
you know what? You can like I said, you amaze them and they'll come back, but don't just make them do math. I mean, how many of you out in the field with your telescope? All right, now I need you to do this math for me. You don't do
You're
that.
right.
I have a question or comment.
What do you got?
I find a lot of people struggle with the scale of things. People know the universe is big, but the scale of things they struggle with. Not too long ago, someone asked me, "Did we ever send anything out of the Milky Way galaxy?" I said, "No." I'm serious, and I said, "You mean the solar system?" They said, "No, the galaxy." And that's not uncommon. Those kinds of questions.
Not even electromagnetic radiation.
So another thing people struggle with is the phases of the moon, phases of planets, and stuff like that.
Phases of the moon is not easy to get across. You know,
People struggle. I think most people do not understand the phases of the moon.
Bob, when
Yes.
I was at the University of Arizona, the first year, the first class I took in astronomy, I knew more than anybody in the class, maybe even the professor, but I got a B in the class because the professor says to me, I got, did well on the test, but I had to write a paper at the end, and I did it on life in the universe, all right, or life in the solar system. And he says, "Well, you know a lot about astronomy, but not my astronomy." And I remember this to this day. He was something. Yeah, but the teaching of it is getting a little better, Bob. I'm going to tell you. Those that are taking it now are starting to get a little bit of the stuff that you're doing, but this is the best way to do it. Absolutely.
Blow them away first.
It's amazing how little people know about astronomy.
Well,
Amazing.
Ryan Gosling, actor from Project Hail Mary. I saw an interview with him, and he's talking about going to another galaxy, and it just makes me go, "Oh, you didn't go to another galaxy."
It's great.
Comment.
Bob, what do you think about one fast thing? Bob, what do you think about the spacecraft coming here, UFOs? Think it's possible?
I'm not going to say it's impossible, but they're going to have one hell of an energy generation method, and they're not going to care about getting back to see their civilization.
That's true, too.
So, I mean,
well, they may be so far beyond what we know. If they look at what we do on the Earth, I don't think they want to visit anyway.
somebody wrote in chat, "I miss Carl Sagan." Yeah, I wish he was around now. He'd be taking some of these guys to task. I think he'd be throwing down.
You're right. Thanks.
I have a comment.
What do you got?
As someone who actually teaches an introductory astronomy class in Macomb.
Yes, I hope it's not insulting.
No, not at all. I mean, how should I put this? The acceptance rate at community colleges is 100%. So you get a lot of students who are not well prepared. And so I have evolved to the point where I use very little math. Calculating the magnification of a telescope is about the toughest thing I do that involves math. And I show them how to do that math.
I've been thinking about. I've got several of the slides that I have that didn't make it. They're sitting at the bottom of the presentation that didn't make it in. Are about the math. I'm thinking to myself, you know what? I wonder if I can do a presentation about the math without explaining what the denominator and everything is. Just explain how cool the concept is. Like, the inverse square law. Show an example of that, or Newton, the orbital mechanics, show an example of that, and that kind of stuff. But the math can be beautiful, but I don't want to have to do a presentation where, all right, here's all of the figures and all of no, just show them how cool it is. There's got to be a way to do that.
I think for most people, taking an introductory astronomy class, it's fine to cut the math. For anybody who's serious about potentially becoming an astronomer or an astrophysicist, they obviously need it big time. But that's not the average person. So I really appreciated the presentation. Really neat.
Thank you. But yeah, the whole thing started with I think it was my last field of view in December when I said I had this astronomy class that I hated and I could have taught it. But now half of the stuff in this presentation we didn't even know about when I was in school. So exoplanets, didn't know about those. Hadn't been to Saturn. See, when I was, had we even did the
Black holes
debate?
are still theoretical when I was in school.
But I think the thing that amazed me is the years that all of the different frequencies of light were discovered. I mean, gamma rays weren't discovered until like 1945. So, and the fact that IR and UV were discovered a year apart is pretty cool.
Well, wait a minute. Jupiter only had 12 moons and Saturn only had 9, right? Right? How many does Saturn now have? What did you say that number was today?
Saturn, easy enough to find out. Ask the Google.
Yeah. Thought you said some ungodly no. I know that Jupiter has about 190 or something like that.
What is this?
Mark Kedzier says he thinks Saturn has 268.
Is that right? Yeah.
293, it says the Google.
They just added some more.
It seems like every week they're adding more.
Yeah.
So
Well,
again, I said I love astronomy, and I said when I took my astronomy class, I was really disappointed because I wanted all the other students in the class to know as much about astronomy as I did, and they didn't get it. They did not get it.
Ain't gonna happen. That's for sure. Well, I'm doing something on Facebook now. I'm doing the moons of the solar system, and I'm going to do the top 20 moons. That's what I'm going to do. That's all, because everything else they're just rocks. Most of them, and I'm getting good feedback from it. People are calling me and talking to me about it, and the moons of the solar system are very, very interesting. Very interesting.
That itself could be a presentation. Practically any slide I had in here could be a whole presentation.
Yep.
I do want to point out that Dale Parton and I are both going to be giving presentations about the moons of Jupiter in July and or August and September.
Fabulous.
So,
great.
So you will hear more moons.
Cool.
Want any input? I'll give it to you.
Sounds good.
All right. We have no more questions for Bob. That'll be it for tonight. I don't think we're doing any gastronomy after astronomy because but everybody be safe, stay inside, try to breathe clean air.
Yeah, don't go out in the asthma-inducing air.
Yeah, don't look at the sun directly. And cross your fingers for good weather on the 25th so we can have a successful picnic followed by observing. So good night, everybody, and see you.
Before you go, I just want to.
Oh, hello.
I'm sorry I'm late, but I am. And I just want to say hello to everybody.
Hello.
And every brief quotation.
Well, happy anniversary, and it's coming.
It was given by Senator Carl Schurz on the night before the American Civil War in the United States. He was in Faneuil Hall in Boston. And he said, ideals are like stars. You will not succeed in touching them with your hands, but like the seafaring man on the desert of waters, you choose them as your guides, and following them, you will reach your destiny. I just want to share that little thing with you today. I'm sorry I'm late.
No, that's the very profound quote. And congratulations on the anniversary of your most famous comet.
Thank you. That was today. Yes. Thank you.
Fantastic.
All right. Well,
Thank you, Mark Kedzier, for reminding us of it.
yes. Okay, everybody, be safe. We'll see you next week. 5 o'clock, Stargate, bring a dish to pass, and let's have a good time.
Can't wait.
Night, everyone.
That's Diane. That's the president of the club.